take a whole day.
Set a high bar that you have to live up to, but I'm sure you will. Thank you. Thank you.
So I'm not sure if we can have it on the screen. Yeah, that's it.
I don't think your mic is not working.
Can you hear me?
Yeah, that should be fine. Okay. Okay, so hi everyone. My name is Bonaventure. Miss Soda said a lot of things. I usually say don't trust the internet. I'm just trying to do my small work, help people the best way I can, right? Yeah, I would have read my bio either because that's going to take a
Can
lot
you
of time.
close the Zoom call, please?
But people on Zoom won't
They
be
can,
able to
yeah,
have
but they have to watch it on the website, not on the Zoom. We can see the Zoom there.
Oh, it is showing the Zoom.
Okay.
Susan, you should close the Zoom here. I
Okay.
can open the Zoom.
No, you can stop.
Right, this way.
You can exit your Zoom.
Okay.
Yeah, now you are.
Okay.
Okay. All right. Yeah. So I think it's going to be a big compilation of many more works, not only mine, that led to a lot of driving forces, a lot of like improvements. So it's going to cover several different aspects that actually align with the vision of like, the Global Surfing AI workshop and the work that Mrs. Susanna and Suda are doing. So one key thing that came into the work was like the lack of, I'll call it lack of integration, specifically about the African languages. So I brought together a lot of my research papers and others, and here, up to today, we can actually see here that there's a classification of the languages that are supported by voice assistant, current voice assistant. This is a little bit of an old slide, but it hasn't changed up to now, sadly, right? Because there've been a lot of research, but still there are not a lot of like integration yet. So if we can see, for instance, on the low resource languages, and on the voice assistant, like the one that we use daily, Siri, Alexa, Cortana, they are almost zero supported, if not almost, exactly zero supported by those languages. Google Translate has more on the language aspect, the test aspect, and recently they added more of like African languages, including my native language form, which was a very beautiful moment because I've been working on it solidly since 2020, so it was a great achievement. But then there are still many more that haven't been integrated, and we can see here that these languages represent up to 2,000 more of the 7,000 that have been announced. So how can we do it? One thing is about the data, right? Like, because we cannot create those systems without data, which is sad. Because if we have, some people assume that we can just train a large language model on like English and then just fine tune. I'm particularly less and less for that approach, but here I was just talking about the lack of representation, where for instance, currently, if you follow the trend, those are the three main large language model built entirely on African languages. This one was from a colleague, I think I forgot the university, but he's a university in Canada. This is from like David, and I was also part of it, and this is from me. And the largest has 23 languages, which is still very minimal compared to the 7,000, or even the 2,000 of like the whole Africa. Now this is when we count only large language models that have been entirely trained on English. but like African languages. But if we now look at everything, the whole landscape, it represents even less than 1%, or just 1%, right? So there's a huge and big gap. So the next thing is about then the data set, because we talked about general like lack of integration, then we talked about data, then we talked about language models, then we are going to talk about the data, right, because it's an important thing. So I've crawled these from Hugging Face, and data set with African language, not data set only with African language. So those, for instance, have English. So for instance, like MC4 is counted. So data sets that have African language included. If we count them all together, they are up to just 3% of everything that exists. Obviously, I've used Hugging Face because that's the way to go today, right? So, and I just made the statistics, and it's still very small. Now, if now move to the percentage of like citation, not citation, but publications, like in like ACL, MNLP, even maybe NeuRIPS type conferences, we have even less than 1% of publication. You can even make the exercise, go on ACL Anthology and crawl the whole paper since 19 something, and then try keywords African language. You won't find many, sadly. So now I wanted to enter the progress part, because those have been problem issues like limitations. But then how have we been working toward building? Because it is not just enough to keep saying, oh, okay, we don't have this, we don't have that. What can we do with the little that we have? So that's where the first project that I started with personally was like FFR. If you haven't read the story, I encourage you to do, because I didn't think it would be what it was or it is today. I just started really because I wanted to improve the communication between my mom and I. But then we had 3 versions, and then from there I joined like the Masakani community and worked with other people, and then we created several different data sets for different purposes, linguistic tasks. So for instance, here is for like name entity recognitions. These are for like news data sets, sentiment analysis, Bible, GTS, free speech, which is recent, the first Pan-African speech corpus, and recently is not included, but we recently released a free Mercury, which is more about a data set of medical question answering for specifically for African languages. And then there's Africa as well, which has been recently accepted as at EMNLP 2023. It's last year, but still in the field considered as recent publication. So then I'm going to talk about the fact that someone mentioned recently the fact that there are low resource countries and then there are low resource languages. And it struck with these because there are some countries which have very low speakers, languages that have very low number of speakers, but still the language is have been extensively studied, compared to languages which have a lot of speakers but have been very little studied. So this is, I'll give credit to Chris because we started this room with students back in Russia in our room, and we really wanted to bring a solution to the issue that we encountered when we were trying to develop FFR. So I'll say I'll give him the credit because of my PhD, he's been more entirely on this. So I'm not taking his credit on what he's done. I'm just presenting it. So the idea of Africa is really to go and a little bit like Ms. Suda and Mrs. Susanna, trying to find what exists on the internet. You know, people have courses on Afon, which is like a very low resource language that people never heard about. So those people have, for instance, YouTube courses where they teach the languages. They have like dictionaries, which maybe are like in paper form. So there is maybe a need to perform some OCR techniques to extract those texts and everything. So it's mainly going out there and find what exists, but what is not on the radar of our eyes. Because if you go on the internet, you try to look for Afon, you won't find anything. But if you go for instance on Africa, it is straightforward and easy. And when we started, we received a lot of like positive feedbacks from people from the community, researchers that we were working with, from people from Google and everything, and it was great. But then later, it was also the fact that people use African annotators a lot, not for free, if not for free. There's been a story about the fact that people who annotated and crawled and curated the data behind ChatGPT, the initial version and then later the improvement, those were Kenyan workers and they're being paid less than $1 per day. But you can even see how much money OpenAI is making out of it. And recently there's like a 12-day something, and yesterday they launched Sora. So there's a lot of profit people have been made of those, but what about people who actually put the time in to help those type of companies to have the data they needed to build those technologies? So later on, Africa emerged as like one of those platforms where people could actually maybe lead a little bit from those. So that was in early days. All the credit goes to Chris, and like he's actively working on like making this more like tangible. So for instance, there's like Africa talks where we invited, and we still invite people from like DeepMind or big companies to come and talk, right? Or people or students as well. And then it's like a community that is growing. Now, next is about then what we do with those data sets that we created and the languages, the models that is out there, and to actually be able to make a certain progress. So in that regard, Chris and I, we started first this, but when we did this, it was actually the first multilingual machine translation. It was accepted at MNLP 2021, so it appeared in the proceedings. That was the first conference right after the pandemic. So we created this first many-to-many African, multilingual African translation. So it was just uniquely between African language, so from an African language to another one. Well, we had English because we needed pivot languages. So for instance, phone is not, we are still like a fight ongoing to have it like institutionalized and taught at school, but it is actively just not in the system. So what we do is like, we first of all go and like look at websites, government, or maybe like article websites that have French, and then we work with linguists to actually manually translate them, which is a painful process. So that's why those languages, English and French, are there to serve as pivot language to others. And one thing that we've realized here is that if we look at the languages that were in the pre-training, so here we tried 3 different approaches, and then we brought this one that we call back then BT and Reg. There have been a lot of improvement already over it, but one thing we found out is that the systems that, the models that already made some of those languages during fine-tuning did better on BT and Reg objective that we kind of like brought in, and the model that did not belong, that were not in the pre-training sets, were actually doing better with this back translation, which were kind of aligned with some of the ideas, the fact that, hey, you just need to stop saying that, okay, let's pre-train on this huge large language model and then just fine-tune because it won't do better. It's important if your data set at the core is inclusive. And obviously, we also got a lot of improvements from like, with like sentence piece blue, ranging from 0.8, 58 to 19 on like several directions. Now, another part of like leveraging what already exists, we have several works. For instance, Masakana did, this is like roughly Masakana 2, but the title was different, and many other works. But then one key thing that these works have shown is the fact that it is important to have an inclusive data set, and it's important that if you have a target language, that you can learn from language that are geographically nearby. So for instance, if I'm working on font, for instance, which is in Benin, I can benefit from linguistic features from like a language which is from Togo, for instance. So that could, in some kind of way, be a type of like augmentation to whatever you are trying to build and improve the quality. Now, in that, there is this paper that really struck me, and which really highlighted, it was published in NICO 2022, I think, and what is this paper is showing is roughly that you don't need a lot of data, you need to be just smart enough and have qualitative data in the target domain that you are interested in. So one of the contributions was the MAFON dataset that was introduced. Then we tried several like transfer learning across different techniques across different languages, and we have those three domains. So primarily we have like the religious domain and we have the news domain, which we mainly focusing on the news domain. So we tried different approaches about combining the religious domain with the news domain and in different ways. So it turns out that I'm not sure if you can see the screen if it's like big enough. Well, it turns out that indeed fine-tuning does help, definitely, because we tried to do some zero shots, which is right here, and then we tried to, which are like right here, blue and CHRF are the matrix. We do not necessarily need to compare them, but they're just telling the same story. So this is zero shot, and this is when we fine-tune for us in both directions actually. So the key message here, if I move this way as well, is to show that yes, fine-tuning help. So using the data in target domain actually does help. Now the next thing is whether it is important just to push or just to throw a lot of data to the language. And this was very funny and interesting, because what this shows is roughly, you can imagine that the news data set that we created were around, I don't know, just 10,000 sentences, right? It's just an estimation. The religious and the Bible domain that we have were from like GW300 and many other sources. But when we, these technically show that if we, first of all, use religious and we augment with the news, it doesn't bring much of performance, which is weird. But it was actually an interesting finding about the fact that us just throwing trillions of tokens from the Bible did not actually help the model performing better in the news domain that we were interested in. So that means that, okay, not just a lot of data is needed, right? Because if not, this should and could have helped, but it did not. That's what we talked about, like strong domain bias here, for instance. But then, what do we need to do then? That's when we we did more domain shift adaptation experiments and result, and these actually significantly improved the result. If we sorry, I forgot those like red sticks to actually show the result. But if we compare, for instance, these results, I can come a little bit back with this one. Let's just look at this. For instance, for Wolof, this is 12.4, and if we go here, yeah, it decreases a little bit. It is not that much different, but it did decrease. So even in that adaptation, it was not super efficient, which was what I was trying to paint as story. But you know, it did help a little bit in some languages, but it's still very marginal. Then we were like, okay, so if putting this in like a whole set of data didn't help, what do we actually need? That's when we then train from scratch a bilingual transformer from English to Swahili, English to Igbo, and then French to Bambara. So this is the threshold, the baseline. And the question was, okay, how much data we need to actually beat that bilingual transformer, which was our baseline. And found out that in most cases, we only needed somewhere around 2.5K in the target domain. So having as much as those numbers of data, good quality in the target domain was enough to beat all those models here, and more importantly to beat the baseline. And that is where the title came from, that a few thousand translations can go a long way, because we realized that with only a few thousand, we are actually able to, in the target domain, we are actually able to bypass, to like outperform several models, even the ones that were largely portrayed. So then this is more, from now on is more about myself, because I am really into the fact that, okay, I know that those portrayed language models, they do exist. I know that I am limited with data, but then how more innovative can that be? Because we cannot always be completely about data, about language, is about the models. We need to be able to do something with the small that we have. And then, so what if we want to train from scratch? And what if we want to cope with the data scarcity and ensure generalization? So that goes back to a paper in 2022 at MNLP that I co-published with like those researchers, African as well. And what we first of all did was like, this is roughly about the Afro-11, the largest large language entirely African that exists so far. These are the data statistics, but I will just go through them quickly. The main thing that I wanted to bring here is about combining a machine learning technique, which is called active learning, and integrating into NLP, because I also saw that it was not well used or enough explored in the field, which is still the case, right? Because some people usually confuse it with data annotation or things like that, which is not just the case. So by definition, AL is just a form of like supervised learning, where you technically have a model and then you have a learner. Then you have a model and then you have a query. So the idea is, how can I train my model to learn to be selective to example that it needs to select such that it optimizes its performance. So that's a lot of select and it. But I'll just take an example, simple example. I may be a teacher. I'm a mathematical teacher, right? And I specialize, for instance, in algebra. I have a pool of like 10,000 students. There's an evaluator that is coming. So I don't have time to evaluate each of the students. But I know that the higher, the more students do pass the evaluator's like exam, for instance, the better maybe I'm gonna get in pay, raise, or things like that. So how do I actually, which metric do I actually use to be able to say, okay, I don't need to I don't need to work with those 10,000 students, but out of the 10,000, actually it's just enough that I optimize the references and the performances and the knowledge of 100 students. So in some sense, it's about saying, okay, I have this large pool, but I don't want to go through all of them. I just don't want to throw all of them to my model. I want my model to be smart enough to know which samples in that big data set is needed for each performance on the downstream task. So roughly that's it. It's been user-oriented and demonstrated in like several ways, like for instance, in like ML for health and drug discovery. I actually discovered active learning when working on a drug discovery project, which was entirely unrelated. So I'll skip through this because it's also an old paper, but I'm trying to do just like a very evolution of everything that has happened. So this was the framework from the Afro-LM work, and when the work itself comes from the fact that in this data set we had some languages that were not included in like existing pre-trained language model. We didn't want to just assume that fine-tuning them was enough, so we wanted to work with the model that has seen them itself. That's where the prefix self comes from, because usually these, as we see here, the active selection query is usually an outside model for us, or in a data collection setup, you can see as like the human annotator that is going to say, okay, this is what is supposed to be, and then these are the samples that are important. But here we just use the model itself. And we tried several experiments on different data sets. And what we noticed was the fact that this model, fairly large, was actually outperforming every single other model which were trained on, like, for instance, MBERT and XLMR, which were trained on more than 2.5 terabytes of data. AfriBeta was like trained on like 0.93, and AfriLM roughly was the lightest and the smallest. Yet it outperformed the majority of them. Even those two, like you can even see here, MBERT has 0 on Hamaric, but AfriLM, which was 1,000 times lighter and 1,000 times trained on less data, had way better performance than MBERT and XLMR and all of the models. And then we tried then to shift and to leverage it on another domain, because these were unused domain. So how would they work if we transfer them on another domain and on another type of task? So what happened is, on the task classification they work, but not that much of a big difference. But when we did on another domain, for instance, movies or Twitter, we can see that that model achieves better generalization in like out of distribution settings than every others, which were supposedly, so for instance, XLMR, for instance, has been trained on, I think it's Common Crawl, which contains like trillions of tokens and which has just, I think, about 5 African languages. But overall, it contains about 100 or 104 languages. So what it shows is that we can build a very powerful model, yet there is data centric and very efficient. And this is like what this work showed. We do not need actually to always rely on like those like large models. We can be smart, find better ways to be able to exploit even the smallest quantity of data that we have to still outperform those models on specific downstream that we're interested in. Then I was like, okay, fine, this work on text, how would that work on audio? Which is where this was transferred then to ASR. So the idea is the same thing. We just want to adapt an ASR model on a set of new diverse languages. But the thing is, we have very limited data. Those are like African, so very tonal and morphologically complex. Obviously, I'm not arguing that African languages have the highest morphological complexity. Many other regions do have, but they still have those. And many of them have labeled data, but we do not have the budget to label them because human label is expensive. So the idea is then, how can we efficiently use the small data that we have to be able to maximize the performance on each language, downstream task and domain? How do we reduce the cost of annotation while ensuring high quality, and how do we increase the model's robustness? This is where I'm writing again active learning, which uses a tool that is called uncertainty quantification, right? Because this guy here needs a criteria to select the samples from the labeled data set. So based on which criteria does he do that? And then I have these, which might be very, very, very fast. It's all based on like uncertainty, epistemic uncertainty. So whether those are like state-of-the-art approaches, uncertainty sampling, bound, batch bound, those are active learning, active learning acquisition functions that all are exploiting the epistemic uncertainty of the model and trying to actually improve that. So, for instance, working with ML, we always work with uncertainty, right? Because, for instance, this is efficient net predicting this image as a typer keyboard, and then the other one as a stone wall. but you can see the high percentage of high accuracy, high confidence, if I would say. So just imagine this being in a medical domain is going to be disastrous because the model is just being confidently wrong, which shouldn't be the case. So roughly, as I was saying, ML and like uncertainty are inseparable, and we cannot like extract them. Even humans, when we want to make decisions, we're trying to put together all information we have, but then as new information comes in, we try to update that knowledge, and when we try to make a more informed decision. So there is that, and I try to put it here. This is the very basic definition of like the epistemic uncertainty, just trying to compute, for instance, the variance of the model's prediction. That is like in a very, very basic form. But then after, there are other advanced techniques like batch bound that I was talking about, that are now trying to maximize the mutual information between the model's parameters and the model's predictions. It's more advanced, but this is the very basic way actually everything starts. And then this is the quantity that we want to reduce. We want to reduce these variance. We've given some samples and then given some like model's parameters to make the model reliable and to make it more solid, more robust. So how do we reduce those? That's what I was talking about, mutual information between those two quantities that will tell us to which extent knowing about one language reduces the uncertainty, one like, entity reduces the uncertainty about the other one. I will pass this. This is, for instance, the formula for batch bound. So this first part is the model's prediction, and this one is related to the model's parameters. So it is trying to reduce this to maximize this quantity. And this is roughly the definition, the mathematical definition of the mutual information, but we just go through quickly. And there are many ways to estimate that is the batch using several words, for instance, deep ensembles and like Monte Carlo dropouts. But I will quickly go through. Here we use MC dropout to compute the uncertainty, and then we have some selections about the uncertainty model rate. This is where we use the free speech 200, and it's better if we talked about the results now. The architecture is the same as AfroLM. We just transposed it, and then we just use an input, a speech input rather than a text input. And obviously the output was supposed to be a text, which is the transcription of what has been said. So what can be seen here is that in those words, so this is the baseline, and these are the model rates. So when we use the baseline, for instance, for width to length is like 49, but when we use those approaches based on like epistemic uncertainty, there is a huge drop in the model rate. So if you compare, for instance, these 0.49%, I mean 49% model rate to 10%, there's a huge gap. The same thing is observed in the clinical domain, and then when we pull those two domains, general and clinical, together, we observe the same compared to the baseline. Now, if we wanted to make sure that it was not just specific to the data set or the domain, so we tried on 3 different data sets that are specific, respectively, from like different domains: medical, general, and this is, I honestly forgot the details of this data set. But roughly what it shows is that our approach compared to the baseline are by far way better. So this is 12% model rate, and this is 15% model rate. There's a huge gap. But all these actually, by using less, almost 40% less of like training samples, for instance. So we have this approach that this shows actually that, okay, we do not need actually much data. We can be smart, and we can exploit whatever small that we have to actually build something that by far outperforms anything that is out there, because when Wave 2 Very, for instance, is like known to be one of, if not the state of the art on like ASR transcription. So people will just be like, take it, fine-tune it on your data set, and then you can get something, which works. I wouldn't lie, it does work, but then we can improve it further by using those like small but efficient techniques. And then we try to do some domain and some like analysis. That's when I was saying we define the uncertainty model rate, right? So what happens here is, for instance, we want our model to be like uncertainty to be decreasing across the route. So when we did compare it, we can see that our method is the red one. We can see that the whatever rate is uncertainty in the model is entirely decreasing across the round. So this is the first round, this is the second one, this is the last one. So obviously at some point there have been like some increase, so that means that there should be some trade-off. But overall we have the same trend across even the general domain somewhere here, where everything entirely decreased from round to round. So this means that we are actually efficiently minimizing this quantity in our model with respect to those samples that we had in our training, which is what we wanted. And then, so roughly this is a speech version of unlearning, trying to use the same technique, but then adapt it to speech input, and then it's showing that it actually works. And people have been using it already, like in real life. Now, as I was saying, there are some trade-off that needs to be explored, and computational complexity, which is more or less the next things I'm working on for my PhD project. We usually need to retrain from scratch, which is computationally expensive, right? So how can we do it better without the need of retraining from scratch? Then there's like another work was like the multitask learning. I will go through it quickly. What we wanted to do here was to see whether we can have a model that is going to be supporting several works. And this experiment was specifically on like phone, which is my native language. So the idea was, can we create a model that is going to be unique to phone, but that will perform well on like two different linguistic stacks. So usually there's like this setup, which is about roughly the hard parameter sharing, which is here, and then again the soft parameter sharing. That's usually how things work on the last layers on multitask learning. What we tried to do was a little bit different, because we tried to bring those two together. And we also tried to, usually they leverage one encoder, which is this guy here, because it goes through several layers of that entire encoder, and then there are specific layers. So here we tried to do something different, which was combining two shared encoders, which was one was general about like all the languages, and then one was very Afrocentric. And then we tried to merge them in a way that they can benefit from one another. So we had two different experiments. One we fine-tuned only on only on phone. Then the other one, one we fine-tuned all languages and evaluate only on phone. The other one was one we fine-tuned only on phone, and we had interesting results. So it happens there, when we fine-tune only on phone, and then evaluate only on phone, the performance was low compared to when we did fine-tune all languages and then evaluate on phone, which is supporting what I was saying earlier, that a language that is nearby, that has maybe more or less the same linguistic structure, could actually be helpful for the language, the target language. And then this goes the same for the other task. This is like for NER, so the score, the performance evaluation metric was F1. The other one was accuracy for the POS. And then we tried different approaches to see in which way was better to actually do this merging here, this guy here. This merging here. How was it better to do? Should we just like addition those two different representations because we made sure that they have the same size, or should we just like multiply them as should we just multiply them? So what happened was we saw that the multiplication versions have more result, which we didn't find a solution back then. I think nowadays there is, but our intuition back then was the fact that the multiplication here acts a little bit as a scaled dot product, which in itself is somehow a way of capturing virtual relationship and then providing a more meaningful and unified representation across the different tasks. So roughly, it is a very promising landscape for African languages. Combined with active learning, it could just be something very more wow. Yeah, so I gave this picture the first time I was giving a talk here, so I brought it again about the bigger picture. It's about like focusing on creating more resources for African languages, which is about datasets and everything. But then it is also about building and scaling AI techniques proper to African languages. I've talked, for instance, about active learning, which is very, like, if you talk with people here in NeuRIPS, they probably know more about active learning. But if you go to EMNLP and ACL, it will just be more blurred because it hasn't been used that much in the field. But I think it's very promising, and then we can even explore it more. For instance, we have matrix blue that are more general. So for instance, you cannot, for instance, use blue to evaluate from an African language to English because it does not exist. You can use blue to perform evaluation from a Western language, from English to an African. Yeah, I think, or maybe I'm not sure about the sense, but there's one way which is not possible, which is why in some cases we have them to use the character F score or F++, which is also more aligned with human judgment. So we could even, on those evaluation metrics, we can even maybe, for instance, in the blue, we have the weighting parameters, right? So we can even maybe creating a new version that we can maybe call a weighted blue or something that is going now to somehow embed the linguistic features of those languages. Anyway, yeah. So I also always have this picture because I'm happy those words actually help in integrating my native language into Google Translate, but I wouldn't like the story just to be ended there because one day those big companies might just be like, I don't want to work or like to provide services in Africa. So what is happening? We can tell them, oh, you guys are being racist or this way. It's the technology, they own the platform. So we should be able to create all those. As you can see, like I covered from the beginning, it's not exhaustive because they are more recent works and like things that even came just a few days ago. But you know, we can cover, we have the talent and we have everything it takes to actually cover everything that leads from speech to text and many more. So we should, as Africans, and I think it's Watson who said it, African researchers should do for the languages what Western researchers have done for theirs. So we shouldn't be relying on like what someone created and then like adapting. We should actually be owning our own technology. So in that way, we could be able to speak freely, have our own researchers. You know, it's not about a race with the Western world or like high resource languages. It's about what we do for our languages, right? So, yeah, I think that is the end. When I grew up, what happened was I was not encouraged to speak my native language. When I spoke the native language at school sometime, I was expelled from class or I was punished, right? It was being seen as a way, as like being illiterate. But it shouldn't be the case because it's not only a way of communicating, it also carries, it's also something that carries value, that carries culture, that carries a lot of other things. So we should actually be promoting those languages. That's why I was talking about a fight because yes, Google first got into Google Translate, but it has not been institutionalized, for instance, in my country, which is something I'm working on with languages that are there to actually make it more impactful. But yeah, we should all strive for that so that like the next generation, for instance, could still speak those languages, because I'm here, and if I don't speak that language, maybe after the generation after me would not know anything about font. And that's bad, because they are losing the part of like their cultural identity, where they come from. So we can actually use technology to preserve those, to build series, to build Alexas that can speak our own languages, right? And then that way we make sure that our languages are not lost. So that was all. It was a long journey. It's not exhaustive, so you can find many more people that are doing the same thing. David, and so many other people that are doing a lot of things here. And they are at NeuRIPS, so you can just find them and discuss those, work with them. And yeah, so you can feel free to reach out. And that was what I wanted to talk about. It's nothing special. So yeah, I hope you enjoyed it.
Do you take some questions?
Yeah.
And if anyone has any questions, can you come to the mic?
I have a question.
Yes.
You said something about this morphological complexity. So having worked in African languages and looked at Western languages and we know French of course, can you tell us something a little bit about the morphological complexity of the languages you're working with, and what are you doing about it?
Okay, so I don't know much about morphological complexity, but I have learned a little bit about them. One thing I have known, for instance, is the fact that I work mainly like with phone, and then when I was working with other people on other languages, then they were experts of those languages, right? So it's like now a collaboration. But on my language, what I've noticed, for instance, is there is never the word for actually expressing that thing. Like for instance, in font, for instance, to say good morning is like neafongo. The idea is to ask you, how did you wake up? Not actually saying good morning. Things like that. So I'm not sure if it has to do with morphology, but those are things that I've learned about language, and I'm still learning, right? I'm not an expert on that linguistic aspect, but I'm still learning to try to integrate it to the research. So even the structure is different. So for instance, there's one example I used to give. So there's the word there's the word to. So that word, given the diacritics or like the accent, has different meaning. So for instance, there is to. You can hear the intonation. There is to, which means country. There is to, which means ears. There is to, which means father. And then there is to, which means country. So if you strip, for instance, that information, those like accents, it loses entirely not only the context but also the word, right? And then there are many examples like that, but that's just one that usually strikes with me. So that is just an example of like how I think that has to do some morphology. I don't know. I'm not a linguist, so maybe that claim was too huge. But I'm still trying to learn about them. But those are like some differences and some like very specific aspects, not specific to font, but that I have been learning about font. There are many differences.
That's awesome.
Hello. Thank you so much for your really informative and interesting talk. I'm a linguist. From a linguistic perspective, a lot of your work is really interesting. Can you provide some tips for people who are linguists, like cold hard linguists, as far as like syntax and phonology, morphology? Those are all their kind of domains. But we're trying to for me, I get more into the computational linguistic side, so I'm kind of like reverse. Our situations are reversed. I think like one thing that I found interesting when you're talking about morphologically complex images, identifying patterns that have already been established in the long tradition of linguistics, specifically with syntax, and wondering specifically within, like, for example, the language families as has been established in other fields, like linguistics and anthropology, kind of how, which are, in Western world, right? That's how we understand them. But in the global South, right, we're trying to re-engineer, recreate, and break into these fields. So, do you have kind of some advice, one, but also some learnings on your way towards more robust linguistic practice?
Good. If I have some advice, I would like to say if I do, but I do know some people. So for instance, there is a paper, Magnet, which is accepted at this conference. It's from a friend, Oreva Arigu, and they're actually trying to bypass the tokenization stage and like building something that is based on morphology of the language. The paper is called Magnet, and it's like with Thomas and like with Oreva from like University of like Washington, Seattle. So that is a paper you should definitely read. What I can also do is maybe like to give you some content, because I know some people who were entirely linguists now who are now switching to the computational side. Some people did already switch, some people are switching. So that is the best thing I can do right now. And as another advice, I don't know, I think that's where you should bring your creativity, because I'm just trying to learn about my language, but maybe as a linguist, there are other things that you might see that you would and definitely see that I cannot or haven't seen. So that's where your creativity needs to come in. And then I think you just need to learn by getting your hands dirty, working with those people, and then definitely, I think that's the best way, to be honest. I wouldn't think of another advice. Maybe someone who was a linguist and then moved to AI or computational linguistics might have better advices, but that is the one that I currently have. I don't know if like it is efficient, but yeah, we can talk just right after. But I don't want to lie either, so I prefer being truthful.
Thank you. I do have one question,
Yes.
because you talked about data labeling and how unlabeled data versus labeled data, and you're moving the the whole process into a technical line.
Yes.
Actually, human labelers there, and then there's unlabeled data, but your framework is moving that problem to a technical framework.
Yes.
And I work with the data labeling industry, and I have my goal is to empower the data labelers, because right now they are being exploited.
A lot.
So a lot. I don't want to take that away from them, so I feel like I want solutions. I want the languages to be better and the languages to be trained well. But I really, whenever I see a technical framework, jumping in the loop between and snatching things and going into it's like a technical problem. The whole thing, we created the problem. Now we are saying technology is the solution.
Yeah.
What do you think on that?
That is an interesting question. So I'll try to escape by not answering this question. But overall, I definitely, okay, so I think that I do not, okay, so let me rephrase. I don't want technology to take over humans. If I move, for instance, to the medical field, which I'm also interested in, I do not want for instance, a ChatGPT, for instance, to replace a doctor. Even though there have been studies that were like, oh, those systems gave more empathic answers. And this is funny because with a relative, a few days before I traveled here, she was going through a very hard time. I was really trying to be there for her. And then I found out that she was speaking, she was like not speaking, she was like discussing with ChatGPT. And then my first question was like, was it not his, because he's not a human, that it was it respond more imperfect? She was like, yes. So I was like, okay, so Diane, we have a problem, right? Because you cannot have a human or a whole lot of humans here that are trying to be there and support you. Yeah, it's like, it was a very like, weird moment, and it's something that I definitely not want to see, because that's why I'm not for the people who want to build AGI. I think that's, sorry for the term, stupid, because there will never be something changed about intelligence. Even like in the medical field, people do 7 years or 8, then after they have a specialization, like someone who is like specializing in like heart diseases can never make a surgery, for instance, on a neurological like matter, right? So coming back to this, that is a good question, right? But we can see it. We can see it actually as a collaboration, because yes, in this, I'm trying to make the process automatic, right? To reduce for instance, to reduce the cost, for instance, that it would. And this was actually, I think the poster that I shared with you was actually targeting that, actually learning with like non-uniform costs for African languages, where the idea was to simulate situations where, for instance, I have a labeler that is trying to label maybe 2 sentences. One is more toxic, and the other one is like less toxic. So technically, the person will spend more time on like the part which is toxic, right? So maybe I should definitely pay it more, right? And then there's usually that process, and then the cost associated with like this data labeling that is not integrated in like those frameworks. So if we integrate them, and the paper unfortunately got rejected because again people didn't understand it, but then I'm trying to improve it and resubmit to another conference. But what it showed was if we integrate those costs, then not only leads to the model performance by high, it reduces the cost of annotations, and then it also improves the informativeness of the sample. So you are not just selecting garbage. So at that stage, we can see it then as a collaboration, because obviously techniques cannot produce or simulate. I mean, they can simulate the cost, but they will never represent the cost themselves. So at this stage, for instance, that project, for instance, was the fact that, okay, let's assume that we have a budget, and then we need maybe to, because it will definitely cost less to use Amazon Mechanical Turk and annotate, for instance, than saying, okay, I'm traveling down to, for instance, like Cotonou in Benin to meet with local speakers and then like working with them, right? So it is about finding a way on building a framework where everyone is actually playing its role, and that paper is actually showing that. So that's a little bit of escape response to your question. Yeah, I do see where I'm threatening, but I definitely still think that there is a way, and I never wanted to see technology take over humans, rather them more as assistants. So even these technical problems, I'm just trying to say, okay, if someone has this issue, how can it ease for him or for her this problem of like gathering data, for instance, using these techniques, while spending less and then maybe optimizing the cost, for instance. So that is my answer. I'm not sure it answers right or correctly, but it's just an escape response to the idea of what I've discussed.
I understand because it's a hard question. The reason I ask that is like people who are actually working, who are from the community like yourself, and who are from a very highly technical background, should actually, think about that and think about, when you are introducing a technical framework. I believe the data leaders and the workers are true experts, because when you are a language expert, you have lived it your whole life, you are a much higher expert than anyone, right?
Yes,
So
true.
they should be really highly paid. But the cost and everything, we have to find a solution for that somewhere else. But I like that you are having a technical framework introduced. I do want to bring that up and say, please, you have access to global platforms that they don't have. So whenever you are on a stage, do not forget them.
Okay, I won't. Thank you so much.
Thank you so much.